Whoop, 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 whoop. Welcome back. Let's go through devices and some ideas on different ways to work on devices in UEFN optimization. This is GameDevMicah. This is video 8. We're going to be covering pages, 28 onward. Trying to get down through all 70 of them in these little 20-minute videos. I'll try and go back and put some notes in them someday, maybe, but I'm outloading the data now. All right. Help me figure this out. Help me with, I know some of this is wrong. Help everyone. Let's talk. I'm GameDevMicah on Twitter, GameDevMicah on Discord, and a Micah Burninghouse on LinkedIn. You can also shoot me an email if you want, GameDevMicah@gmail. Devices. Call them as fast as you can. Disable any subcomponents you can. Exclude the devices from HLOD if you do not need to see them at range. Do that. So you have the option to exclude from HLOD. You have the option to what type of batching you want to use. You want to test each of your UEFN props to see if they'll do instancing. If they do instancing, use instancing instead of the merge mesh. If you can, try not to ever generate the merge mesh, and that will save you on your package size. But not everything instances, so you may have to do it if you don't want to make custom instances. The loading max draw distance, try and set that so you can cull things out. Culling things out will reduce the cost of rendering. Culling removes something from rendering, but it won't reduce your spatial thermometer that much because the item or actor will remain loaded in the scene. Spatial loading, or HLOD system, will actually let you unload the actor. So using that to cull the actor via HLOD is the way. So check to see if ISMs work and use them if you can. If not, try not to even include it in the HLOD, or you could use a merge mesh, but realize that's going to create new meshes for you and add to your package size. Setting a max draw distance would try and visually cull things earlier, which would be good. Devices, components. Devices are made up of many components. Each component can impact your local scene, memory, and game performance. Anything that is part of the device that you can turn off, deactivate, or clear of data will help to reduce that device's impact on the system and improve frame rates for your players. Devices are Unreal blueprints which will load all references in them into memory. Reducing down texture selections and materials will help to reduce the memory impact of devices in your scene and increase your frame rate performance. If you can accept a device with the attached light component turned off by unchecking effect worlds, you should do that. If you need the light, reduce its impact radius and length of distances, and consider turning off shadows to cheapen up the lights on components. Devices include options for visual culling at distances, net replication, which I don't know if it really works, culling at distances, sound and audio ranges, spotlights, and other types of components. The shorter reach of all these effects, so like the shorter attenuation ranges for sounds and things like that, will help the device be used less and have less of an impact and allow better frame rates. And more, so less is best. In the outliner, there's an option to unhide actor components, and then you can see what each actor is made of component-wise, which can help you to see that the amount of stuff and maybe what things could be disabled. You can't really delete stuff from devices since they're pre-packaged devices, things from Epic, but you could disable their effectiveness in the world, such as with a light, disabling the effect world checkbox. All right. Niagara emitters, CPU versus GPU. This is a very cool and important one. You can choose where the Niagara system runs. The GPU is 100 times faster than the CPU at doing this type of work. What you want to do, though, is you'll have to set some fixed bounds. What bounds are is you're saying for this emitter, where do we expect the particle to ever go at most? And we're saying if it goes outside of that, we'll delete the particle. And if you're looking further away, so like that none of that area is in your field of view, we'll call the system too. So that's what these bounds do, is they help to frame up from the GPU when to call the system based on if you can see it or not. So setting some bounds isn't that hard of a thing to do. You don't need set them as small as functional for whatever wherever your particles are going to go around, how far they'll go from the center point, and that will help you call out systems when you're spawning individual systems. The best thing you could do is not spawn individual systems, but Niagara data channels are not exposed to UEFN, even though they are used in Fortnite. Niagara data channels would be the way for us to unify our emitters, and it's just not exposed in Fortnite yet. So they are individual emitters, so you want to tune each emitter you spawn to be as light as possible. It has the least amount of data in it and activity. Known issues. Niagara on switch / low-end scalability devices. It's a work in progress. The default Niagara effects type, which is included in the system, will call a system and never re-enable it based on that effects type. The option to fix that, which is to turn off the system, or well, rather to just make a different default effects type that does not call the system. Instead, we'll just like pause it or restart it. To do that, you need to modify or generate an effects type class in Unreal Engine, and then migrate it over or copy it into your folder. It's super easy to do. Just the effects types class is not exposed in Fortnite from what I saw, so I just had to make it that way. Here's an example of what it is. The max time without render. Right here you can see cull proxy mode is set to none. That way it won't cull it. What it's set in the default effects type. Oh wait, maybe this is it. Too restrictive because cull proxy sets to null. Cull proxy. So I change this right here is what's up. Changing this to pause instead of null will let the Niagara system pause there, and then when you look at it, continue to simulate. And that's only on the absolute low end that it will do this. So you have to make a new effect type in order to, because you have to have an effect type assigned to all Niagara systems. So in that new effect type that you create in UE5, go ahead and set some ranges that you want and make sure the cull proxy mode is set to something that isn't disabling it once it happens. And that will fix that piece on low-end devices. Yay! Bulk editing actors. This is a cool tool I want to make sure you're aware of. If you have the same class and structure, you can edit subclasses to it using a bulk property matrix tool. So if you have an actor with a static mesh attached to it and it's used in the world for all your actors and you have like 1,000 of them, you could select all 1,000 actors, and since they are actor static mesh, the same hierarchy, it will let you pick the static mesh sub-mesh component, and then you can edit them all at once. You could change them all to the same mesh, you could turn off shadows on them all, you could change them all that use the same material, you could change the static mesh on them. So like you could select all your doors and change them to a different door this way, rather than having to go out and find them all in the world and do it like one by one. So use that bulk property matrix and see what type of things you can edit with it to save you time versus touching each individual piece of the world. Replacing selected actors is another way to automate work. So you can select actors, and then based on the last actor you touched in the content drawer or dragged into the world, you'll get this option, recently placed actors down here. So say you have built yourself a base that's red, and you want to change all the red walls to blue walls. You could go ahead and replace the actors this way with your blue walls once you've selected all the red walls, and do it in one action rather than changing the settings on each wall individually.